Thank you. And yeah, this was not a long planned talk, but was the opportunity. And I said, wow, I didn't realize that there were repeat talks in 380, but I got introduced or invited to come back. So I said, I'll take that opportunity. And so the title, Service Robots Are Here Too, is basically the same title I gave 2 years ago, except with the 2 at the end. And things have changed a lot. And one measure of success is that we were a startup. At that time, we were trying to raise Series A funding, and we're still here. So that's a good success. Thank you very much. Yeah, success happens. What? That'll be the next. Well, no, let's hope that we stay around. So I want to start with just sort of what is a robot is always fun. If you want a really fun time, go to a robotics conference and ask somebody what a robot is and watch them squirm. And so I take a shot at it, maybe for fun. But what I find is if you try to say what's a robot, it's hard to answer. If you try to make a taxonomy, it's actually much easier to do. And so I like this taxonomy because it gives us 4 classes. So robots in factories are autonomous, meaning they do the same thing over and over and over again. Nobody's doing anything. There's a big switch on the wall. When it's turned on, the robots do their thing. And in the old days, it was just a precision motion. Today, it's getting to be more and more vision guided, and so there's more choices that they make. And this is kind of a classic industrial robot that I showed here, which is a welding robot. But if you step back and say, well, where else are robots used? You have sorting robots, and you have robots that will take things off a conveyor belt with an image recognition system, figuring out what's there, what the pose is, and then grabbing it properly and putting it into the right pose. And so you can see some robots working really fast and doing things. These are all constrained environments. You see robots doing things in factories, but almost always behind cages, right? And that's changing today with Baxter, the Rethink Robotics, and with Universal Robots. So there's starting to be some robots that can be around people, industrial robots with arms, but that really is the exception. The vast majority of robots that are out there are inside of a safety cage. You can have remote-controlled robots, and the most classic example of this is the Intuitive Surgical Da Vinci system, which is actually doing surgery on people. But there's almost zero autonomy in this. The only thing that they'll do autonomously is pull out. Everything else is controlled by a surgeon. And so really this is a very sophisticated tool for a surgeon to do surgery that lets him overcome any kind of tremors that he would naturally have in his hand because the system can filter that out. It allows the surgeon to rest. If you think about doing a 7 or 8 hour surgery and you're trying to hold on to some device inside of somebody, especially if it's laparoscopic, you have this very expensive thing. And what do you do when you need to scratch your nose? You tell the nurse. What do you do when you need to rest your arms? You really can't. But with this system, you can basically clutch. System stays put. You can shake your hands out. You can go on and continue the surgery after 4 hours. So powerful, but remote controlled, and there's no autonomy. And then you have mobile remote-controlled robots, and this one is most popular in the bomb disposal robots that came out of the most recent wars in the Mideast. Basically, in order to deal with uncertain radio waves and avoid jamming, they'll typically run a fiber optic cable out, and so the robot really is just a tethered remote control, just like I had when I was a kid, which I figured out as I was coming in here is about how long this seminar has been around since I was a kid. But it's a very, very sophisticated version of that and obviously ruggedized. And then finally, you have both autonomous and mobile, and that's really why I want to talk. Autonomous and mobile, though, still begs a question. There's still a way to break that down. So I put the Google car here as an example of, first of all, I don't know if we all agree that that's a robot, but I would assert that that's a robot. It's got sensing and actuation, and it moves around the world. And even though it doesn't look humanoid, that's not, in my view, a requirement for robotics. As a matter of fact, none of these look humanoid, and I argued that they're all robots. But the question is, where does it have to go? So that car isn't going to do very well in this canyon, right? But you've probably seen videos, I should have put one in here, of Boston Dynamics robots, the big dog that can basically run on this kind of terrain. So people are working on robots that can go here. And drones, of course, can go here, which are mobile robots of a different sort. They're not on the ground. But this is still challenging. It's still expensive. You can't go to the store or go on Amazon and buy a robot that's going to navigate this terrain. Roads is a little bit easier, right? Obviously you get that flat. Roads have this problem that there's other vehicles on them that are going at relatively high speeds, and yet we're able to start figuring out how to do that. You know that there's autonomous vehicles. Autonomous trucks are now allowed in Nevada. We've got the ability to test autonomous cars with human safety drivers on the roads around here, and I'm sure you've probably seen them. Obviously, major work on this came out in 2005 out of Stanford with Sebastian Thrun's work and winning the DARPA Grand Challenge, and later 2007 the DARPA Urban Challenge. So mobile, and actually as far as I know, every major car company has a lab doing autonomous robotics here in Silicon Valley now. So this is an area where things are really going fast. Are those service robots? I would say probably, right? Is a taxi a service? Is a limousine a service? Absolutely, right? So these are robots that are providing a service to people. And this is relatively new. You can't just call Uber and get an autonomous car today, but in the near future you will be able to. Sidewalks is another domain. Sidewalks is, this one looks easy, right? It's like, oh, that's just flat. You just build a little car and you drive it down there. And maybe you could on some sidewalks. And so there are companies coming out. As a matter of fact, the founder of Skype is now leading funding and leading a company that's doing these, it's called Starship, which is these little six-wheeled robots that are aimed to go down sidewalks. But the secret there is they're going to do a site survey of the sidewalks before they commit to doing a domain. So they're not doing arbitrary deliveries. They're saying, in your neighborhood where your sidewalks are in good shape, we'll do delivery, we'll map out everything, and we'll tell the robots, don't go down that street because the sidewalks look like this, right? And so it is possible to do what robots do, what mobile robots do. And finally, you have indoor spaces. And commercial buildings have a particularly nice feature, which is that we have the Americans with Disabilities Act in this country, which means that you have to have a ramp. We have a ramp here in this room that has stairs. So you have to have a ramp. There has to be a way for somebody in a wheelchair to get in pretty much anywhere in a commercial building. And that turns out to be a really nice benefit. Like curb cuts help bicyclists, this helps robots. And so that's what we're taking advantage of when we try to put robots into commercial buildings, and we've started with hotels. I'll say more about that later. But you still have these kind of places. And I've been now for the last 3 years putting robots into commercial buildings and not putting them into some commercial buildings. One of the issues is safety. So when you have a staircase, and these staircases are pretty modest, but when you have like the Grand Budapest, if you picture that one, you have a potential for harm if a robot would fall down the stairs. And so you have to pay a lot of attention as a product designer to say, what are we going to do to make sure that we've got safety covered? And it's not enough to say I have a keep out zone. Because if you believe that your navigation system is 100% perfect, then sure, you put a mark on the map and you keep it out. But if you believe that there's some chance of failure there, you better make sure you've got a way to detect the ground. And again, you assess the harm. So Roomba has one sensor, a very simple sensor that basically looks for a cliff and does a cliff detection and locks out the motor if it's not there. That works fine for Roomba because it weighs, about 5 pounds or less, 1 pound. It's not very heavy. And so if it fell down the stairs, it's probably not going to kill you. Right? It's going to hurt, maybe bump off your leg or something, but it's not going to kill you. If you have a 100-pound robot rolling down the stairs, it's a different story. If you have a 300-pound robot, it's really scary. And so thinking about the safety implications of what could happen if, it turns out to be really important, and a space like I just showed here is a challenge.
Didn't Dean Kamen actually, with his iBot wheelchair, solve the stair problem?
So Dean Kamen built a wheeled robot that could go upstairs. Have you seen one in practice?
Yeah.
A lot? I mean, do you see it go around?
Not a whole lot. They're extremely expensive.
It's expensive and it's hard. It is possible to build a robot to go up and down stairs. The relatively less expensive ones tend to rip up the stairs. You can use tracks and you can get up and down stairs. But you still have to think, even in that case, whether you can get up and whether you leave this thing autonomous. It's fine if I can go up and down stairs, but what happens if I come sideways? I trip over. I have a lot of stories. I'll tell you one about these kind of unexpected things with robots out in the wild. We had a situation in the first hotel we were in where all of a sudden we started getting failures. Every time the robot would get to the 4th floor of the hotel, it would get stuck. I'm like, what's going on? And it's stuck in the elevator. Like, I say, what do you mean stuck in the elevator? I mean, actually, the wheel is stuck in the elevator gap, right? And how did that happen? Well, it turned out that the elevator guy came out to fix the elevator, left it a little bit out of whack so that it wasn't level. The robot comes out, pitches forward, sees the ground, thinks, oh, there's an obstacle, I better look for another path, turns, falls in. I couldn't have written a better test for putting the wheel into the elevator than what happened that day accidentally. Now, so you can just imagine that same, other things like that. If a robot's designed to go downstairs straight, you've got to ask what happens if it goes sideways and tumbles. Same safety question. In that case, what we did, by the way, is make the wheels wider so they can't fall into the gap. Then you solve that problem. Because you could try to solve it in software and say, I'm never going to go 90 degrees, but that ends up being a lot of special casing, and then you're adding other complexity and failure modes. Did I? Yeah. So this is where we're focusing on the kind of mobile autonomous, and those are the service robots I want to talk about. There certainly are other service robots. The other thing I'll say while I'm on this topic of what's a robot is just, robot is just a kind of technology, a kind of automation technology. The word robot comes from a Czech word that means like servant or slave. Your microwave is also your slave, right? It does exactly what you tell it. It's right, and it even has sensing and actuation. You could argue that your microwave is kind of a robot. We don't think of it that way. We have, over the last 150 years, developed all kinds of technology, starting with, 150 years ago, starting with tractors in the internal combustion engine, and things that basically make us more efficient and more efficient. Technology's been coming for a long time. Robots is a name for one class of technology. It's not the only thing. And I bring this up because there's all these conversations going on about, oh, now it's time for, like, robots are here and they're going to take all of our jobs and there's going to be nothing left for us to do anymore, right? And I think we're a long, long way from that. And I think that may be a false worry. Every time we get new technology, we end up creating more wealth, more jobs. The economy grows. There is displacement. I don't want to underplay that, but it is something we could talk about later if you want. So this is just an example while we're on mobile robots. Here's a robot that's mapping a hotel room, and this is a tour de force of cinematography. Me holding my cell phone in one hand and the joystick to control the robot in the other. And the map that's getting created is up in the left, and the robot itself is, you can see it driving around from the cell phone perspective. But notice how the map, as it's driving around, is getting filled in. This is what's called SLAM, simultaneous localization and mapping. Actually, in this case, it's just mapping. There's no simultaneous, it is localizing, but it's not driving it. It's not autonomous in this case. I'm driving it. And then when I'm finished, I'll have it autonomously navigate, but it won't be doing mapping anymore. The mapping is done. So we kind of separate those two phases. But what you can see is, as it goes along, the map basically expands and continues. And we do this practically today by just driving the robot with a joystick in a hotel, building the map, and then labeling the map with the locations you want to go to. I'll stop before it goes into my bathroom. Yes?
It's using LiDAR right now, or is it just?
That one was actually using LiDAR, yes. And that's a typical way to do mapping. When I was at Stanford, a long time ago, but not as long as some of you have been here, I took a class in mobile robot navigation, and we had sonars. We had 16 sonars in a ring, which is like a LiDAR with a lot less points. Right? The LiDAR basically gives you a really nice picture of what you're seeing along the way, and almost looks like these are straight lines, when in reality they're just a bunch of points put together. Sorry. So what do we want? Why do we want robots? Why do we care about robots? And if you were here the last talk, I apologize. I probably showed this one before, but this is the classic use for a service robot, bringing me a beer. We built a little web interface. This was when I was at Willow Garage with the PR2 robot, and basically programmed the robot to open the refrigerator, pick the right beer, so it actually had a little bit of vision, but a little bit of vision because, see, the beers are lined up in nice rows, so we didn't make a hard problem of it. And then we had to add a cup holder to the robot because you have to somehow be able to carry it, and then close the door. Some of this is like from here on, the robot goes autonomous navigation. This is completely autonomous. The other part was autonomous, but it was autonomous in the way that industrial robot was. We had programmed each step. So go find the door and then open it. This was completely open loop, opening the bottle, which is why it's kind of and we made a mess. But the cool thing about this application was that this was done 10 years ago now, almost 10 years, no, probably 8 years ago now, and was demonstrating a combination of autonomous navigation, the ability to interact with things in the environment, and it was incredibly expensive to do. The whole platform. We built the robot operating system and the robot, and then on top of that, we spent a week to build this application. So the application was simple. That's the good news. The bad news is it was only used that 1 week. We didn't serve beer to Willow Garage people for the rest of the time for a couple reasons. But also, it wasn't easy to keep applications like this running as you're kind of continuously developing the underlying system. And that's a really differentiator from where we are today. 8 years later, we're putting robots out in the world, and they're doing their same task over and over again, and doing it, reasonably well. This was another example of what you might want a robot to do. If I can make it play. All right. I have no cursor and no control of my computer, so I'm going to cut out in a minute. This was a video from, this was a work that was done at Berkeley.
See your cursor now. Above it, E1.
Yeah, but it's not moving. And escape isn't doing anything. This is a Macintosh. This isn't supposed to happen. Hold on. No, I unplugged it. Wow. I've not seen this thing get hosed like this for a long. I mean, this computer's never done it. I'm going to reboot, and I'll just keep talking. So that video is and I'll show you the video when we get back, but that's the robot with 2 arms trying to fold a towel. What's interesting about towel folding is that where most things in robotics, you have a hard object that you can have a nice model of, there's really no good way to have a model of a towel. You model the towel as kind of a blob on the table with a color, and then you kind of reach into the blob and squeeze and hope you get something, right? And the algorithm for doing this was basically that. It was reach into a basket, close your gripper, lift up, and see whether you got some of that color in front of you. And then there's a long stage of trying to figure out what you got, right? And then there's a theorem. It's actually it's not that theoretical, but there's a theorem where when you hold a towel like this and you look at the lowest point, it has to be a corner because it's a rectangle. And so you grab that corner and then you let go. Is that not true?
Well, I can imagine counterexamples where you're grabbing something and maybe you grab all 4 corners at once and lift it. The lowest point can't possibly be another corner.
I'm going to have to go back and look at the proof.
There must be an ad.
I'm sorry, I wasn't trying to heckle.
No, it's okay. I'm trying to do things at once.
Steve's used to it.
I get it all the time.
Well, you're sending a very flexible towel. The towel might be a little, needs washing, might be.
Your point is well taken. There are one can imagine there are lots of approaches you could follow. grab something, lift it, then find an edge and lift that, then find a corner and lift that.
Yeah, exactly. I'm sorry about this. I have no model in my head of why that thing crashed, but I'm going to be brave.
It's a computer.
Yeah, but
Demonstrate your point that you cannot count on the robot not falling downstairs.
yeah, thank you. So there you go. So there's the towel folding. If you agree that sometimes my theorem works, which is a beautiful thing about theorems, the goal is then to get a second corner. So this, in the first version, when they first did this, took a couple months for a graduate student to kind of get all these actions together. This little move right here is how you get lots of hits on YouTube. It's a beautiful thing. And then stack them. And so you have this vision of, wow, this thing can do this. And then you ask, how long does it take? And this actually got in the press. And one of the cool things about the press is they sometimes get the numbers wrong. So the reality was, it takes 25 minutes per towel in this version. The press reported as 25 towels per minute, which would actually be pretty good. But it matters, the order. This is Peter Abiel's group at Berkeley, and they eventually got the time down to 3 or 4 minutes, which is pretty good. But for this robot at a discount was $280,000, and it just doesn't make any economic sense to do that work. And kind of got me thinking, how are we going to build a robot that can actually get out in the world? The other example that I always like to show is this a project called Robots for Humanity. This is a man named Henry Evans, who was a Silicon Valley CFO, Chief Financial Officer, and tragically about 13 years ago had a brainstem stroke and was left mute and quadriplegic. You can see that he's using a letter board to communicate with his wife. He's got an on-screen keyboard and a mechanism where a camera tracks his eyes, or his glasses, so that he can move a cursor on the screen. And fortunately for him, he's got just enough movement in one finger to be able to click a mouse, but he can't pick it up. He saw this PR2 robot on CNN and said, hey, can I use this as my external body? Send us an email. And because it was Willow Garage and we could do that, we tried. First thing he did after he got access to the robot was turn the robot on himself, drive it over to his face, and we're like holding on to the run stop. What's he going to do? And he reached out and scratched his itch. It was the first time in 10 years he had scratched his own itch. And it was this magical moment. And for me, it was kind of a life changer. It says, like, I've had people come up to me and say, you work on robots? Why? Do you hate people working? I was like, no. What I like is giving people independence. And I like helping people do whatever they're trying to do, whether it's take care of themselves or whatever. Here's Henry shaving. This reminds me, I always like to tell a story about this particular project, because the shaving project, because Henry, they spent a lot of time, we had a collaboration with Georgia Tech, and Henry spent a long time, he really wanted to shave himself. And so we put a force torque sensor on the little electric razor to measure how much force he used. And we also had a version where his wife could shave him. It turns out he presses 10 times harder than his wife. Which is one of the reasons he wanted to do his own shaving. The other one just being basic dignity and wanting to do things himself. These are all videos, by the way, of him using the robot to try different tasks. But the interesting thing about the shaving one is that when you realize that he wants to manipulate his face, he had actually designed the user interface. He had designed an interface that was Cartesian. So in other words, you can drive the robot base using like a joystick, or an on-screen keyboard, on-screen joystick. And then he could select which arm he wanted to move and whether he wants to go up, down, left, right, forward, back. And then you have the razor in there, and he's got a button where he can turn the razor on and off. So you think, well, that should be enough to let him shave. Even though you think about it, you're like, well, he's moving his head in order to control it, and so it's going to be a little bit tricky. So you need some way to, it gets subtle. Like I need to put it here, let him do his shaving, and then kind of time out after a while and back off, and then he can do it again if he wants to keep going on the same spot. But it turns out that Cartesian motion is really, really hard to do, especially if you're trying to control the whole thing with your head, and he's not really fast with the mouse. But as robotics people, we can do something much, much better. We can model his head, even if it's a really dumb model, like it's an ovoid. And then you can show that ovoid to him. Maybe you can even project a video onto it of his face, and then let him click in the video, and basically where that hits the ovoid. You compute a normal, like 1 centimeter off, and bring that blade or the razor to that spot, and now he can shave. And so by using, basically math, right, to figure out, and motion planning for the arm, to let the user basically click in 2D and let the robot do that. It was actually a 7-degree of freedom arm, so there's 7 degrees of freedom motion planning that have to happen to get it there. He doesn't have to do all that motion planning because it's even harder than I described. When I say Cartesian motion, it's actually ambiguous, right, because the elbow can do this and you can have the same spot. And so that's one of the hard things about robotics, figuring out what to do. But we can put all that into a program and say, when you want to hit this spot, here's the motion that you use, or better yet, let a AI planner do that computation for you.
Scott, do you want to put his name up there with you?
I guess not. Scott certainly funded the whole thing. Just as a side note, this was I like to show this project. This is a video that was done more recently, subsequent to this, where we funded a team of undergraduates, senior mechanical engineering design project, to basically build a robot. It doesn't have to be this whole very expensive robot. This was about $5,000 in parts or less. That lets Henry basically do the same thing, control this thing on his table. I just recently went up to visit him to see this project and what's going on with it. The interesting thing is how the project's wearing, because a senior project is like a first prototype, it's not a product. And the thing that wore out first in this project was the table. You have this cantilevered table and you put this weight on it that you weren't expecting, and that ends up being the thing that is failing in that whole project. So you have to replace the table. The rest of the robot's kind of okay. Henry was very happy to do this.
What was he doing there? It looked like he was scratching his forehead? Or...
Scratching his forehead, yeah. So he basically positioned, he commands this thing, and you could see it was not a very precise robot, right? But it didn't need to be. All it needed to do was basically hold something here, and he could do this and scratch himself. And, from a robotics point of view, this is a terrible robot. I mean, in terms of like its fidelity, in terms of any measure you would use of a robot. From Henry's point of view, this is like the robot that he's always complaining, it's broken, I need somebody to come up and fix it. Because it's aspirin for him, not a vitamin. It's something that he really feels like he needs. His alternative to using this robot is to call his caregiver and have them come and do this on his head. And he estimates 20 to 30 times a day he's got an itch. And you think about how annoying that is to ask 20, 30 times a day for somebody to scratch your head, and you see why he likes this.
Also probably a wonderful size for a school project.
It was perfect for that, yeah. It was a really good senior project, and some senior projects don't see the light of day. This is one that's now 3 or 4 years past the students graduating and still being used, so it's pretty cool.
That's a lot better than scratching your face with a quadricopter drone.
Yeah, it's very creative. You could do that. You could also shave with that if you're really good. Okay, so I just wanted to say a little bit about what's going on in robotics more generally, and then I'll come back to what I'm doing. And I should watch the time. Am I 5:01? Okay. Okay. So global robotics investment is up. I should get the 2016 numbers. I don't have them yet, but it's been a really significant growth in 2015. And 2016 may be flat compared to 2015, but I'd be shocked if it was lower than 2014. You see a lot more VCs willing to take your call if you're trying to pitch robotics in the last couple of years than you did for years before that. And so you get more investment. Also, there's been a lot of investment around drones and kind of other. There's a wide variety of robots out there. I try to figure out the reasons why this may be. One is successful exits. So Kiva Systems, as you may know, was acquired by Amazon in 2012. They've apparently got more robots in use than any other company in the world, even more than Foxconn. I think they're on the order of 100,000 robots is what I heard. So these are robots that are carrying pallets and moving them to people instead of having people walk the pallets in order to fill up your Amazon order. So when you ask for something, the carts, the stuff is actually coming to the people who are going to pack your box. The one in the middle is called Little Dog, which is the smaller version of that robot I described that could go in the woods. This one probably could also go in the woods. Google bought Boston Dynamics, which is that company, and 3 Willow Garage spinoffs, and a number of other companies in 2012, 2013. Unclear what Google's doing with all those companies or what's going to happen with them, but they've done some really cool stuff. And the latest Boston Dynamics video is a similar robot to this, but with wheels on the back legs, so it can it's like skating and jumping and doing all kinds of cool stuff. Aldebaran was a relatively early robotics company that was acquired by SoftBank in 2013 for around 100 million reputed. And Cruise Automation was acquired by GM in 2016 for $1 billion. So one thing about a field of endeavor is that if you're getting these kind of exits, you've got VCs who are saying, I might be able to make some money here if I invest. And so then investment goes up. The second reason is that you get some compelling demonstrations, right? So there's a lot of people successfully demonstrating autonomous cars. And I'd still be really nervous in an autonomous car in a snowstorm, but I've driven one on the, and this was probably 4 years ago, I got to ride in one. 3 or 4 years ago, I got to ride in the Google car on 101 and on side streets from the Google campus up in Mountain View. And it was no more scary than driving with my 16-year-old. At the time, it was, and I'm sure it's getting better. And these smaller ones, like the one that's in this picture, are designed to only go up to 25 miles per hour, which means that it's not going to be scary at all. I don't think it's going to be like being in a shuttle or any other bus. And so, those kind of compelling demonstrations mean, I can see where this is going. I can see where it's a big deal, and it's pretty clear that autonomous vehicles are coming.
So the Lexuses have been on the freeways now? Because I haven't seen any of them on the freeways. I've seen the Apple autonomous car on the freeway and another company.
I haven't seen the Lexus. I've seen the Priuses, but there's so many companies doing this.
Yeah, I know.
Yeah, but again, in California, there's always a person in there who can take over today.
But if it's Ford, they're sleeping.
What?
If it's Ford, they're sleeping.
Well, there was an issue with I think one of the reasons that Google stopped, they had a program where the employees were using the robots, and one of the issues was that people weren't paying enough attention driving those cars around or having those cars drive them around. And then they weren't actually safety drivers anymore. They were reading a book or something. And Google said, wait. We're not ready for that yet.
Actually, sleeping is not the issue, Andy. The issue is a thing called the Purnell test. The Purnell test, which is from the sci-fi author Jerry Purnell, is a couple having sex in the car. That's all the cars do.
Oh,
No, it's the autonomous vehicle equivalent of the Mile High Club.
How is that a test?
That's a
What are they
test.
testing?
all right.
They're testing.
I'm going to go on.
Moving on.
It's not actually a test.
The third reason is that the technology is finally here, and I like this curve on the left. That's a classic Intel, how fast are your computers architecture curve. The red line is mine. The red line going across is how much compute it takes to compute what you can see in real time. Now that's not a perfect line, but that's an estimate. So below that, it doesn't matter if you don't have enough compute power to basically read your camera inputs in real time and make a computation and decide whether to avoid something. Whatever cameras, whatever sensors you have, you pretty much can't put out an autonomous robot. It's got to react in real time. And so my estimate is that we crossed that line around 2005. The line where you can have an affordable amount of computing, and you can actually do this. I may be off by a year or two or three, but clearly by 2007, 2008, you were definitely doing this not only in cars, but even on mobile robots, because that's when the PR2 could do it. And a few years before that, you could do it, but it was you were using a lot more computation. You had a much bigger computer box, and it was limiting the system dynamics and cost. So the other thing is, of course, the robot operating system is open source software that works across a wide range of sensors and has a ton of algorithms in it that we invested, some number of tens of millions of dollars in while I was at Willow Garage. That led to a reasonably robust system, and a lot of the startup companies that you're seeing, including mine, are using ROS as a starting point. It's not commercial code, it's not completely hardened, but if you start with that and then you start adding your own testing and hardening, and you can make it real. And then the other one that was a big deal was in 2010, the Kinect sensor came out. That was a video game sensor, but that was a $200 or $300 3D camera, where before you had to spend thousands of dollars on a calibrated stereo system to really have any sense of 3D. So all those things happen at the same time that has caused it so that now, over the last 10 years, we've got a serious number of robots and service robots coming online. So some of the challenges, one of the biggest challenges is inflated expectations. I blame Hollywood primarily, and I blame the fact that when we think of robots, we think, oh, that's a servant. That kind of notion that robots are humanoids is actually problematic, because when you see a robot, especially you see a robot that looks like a person, you think, oh, I can talk to it, and it's going to understand me, and I can tell it to do things. So even our robot, which doesn't look that much like a person, I'll show you, people will walk up to it and say, bring me a gin and tonic, and then be disappointed if it doesn't. We consciously don't have the robot speak for that reason. I'd rather be mute and sort of ignore the request than pretend like I knew what they were talking about and bring them the wrong thing or whatever. The second big challenge in robotics in getting service robots going is use cases. So coming up with a use case that provides enough value to cover the cost of the robot to whoever's using it so that they're willing to pay for it, and is doable repeatably and reliably, is actually quite a challenge. It's easy to go to people's home and you ask them, what do you want a robot to do in your home? And they give you pretty good answers. Everybody thinks about this, oh, I want it to do my laundry. Like, well, don't you have a washer and a dryer to do that? Well, but I want it to pick up the dirty laundry off the floor and put it into the washer and then move it into the dryer when it's done and then take it out and fold it and put it back in my drawer. That's a hard robot to build. And especially, what are you willing to pay for it? Well, I paid about $1,000 for my washer and dryer, so maybe $1,000, maybe $2,000. Like, sorry, maybe for $500,000 I could get you a robot that does some of that. But even the PR2 robot at $400,000 list price, and let's say I reduced it to $100,000, wasn't able to do that task for a whole bunch of reasons, starting with there's probably, with high probability, stairs between your washing machine and the floor where you want me to pick up the laundry from. And so it's all a really hard problem. Another thing people say, well, can you, how about do the dishes? And that's also really hard for reasons that we as humans don't even think about. You reach into a dishwasher and grab a plate and pull up. What happens is that whole tray comes up. Right? What you do when you don't realize that you're doing it is you actually wiggle your hand or lean the plate over so that it comes out. It's actually kind of wedged in there. And you don't really think about that. As a human, you just naturally do it. We adapt to these things. But when you try to program a robot to do it, you somehow have to start programming all these wiggles and stuff in and feeling the force and realizing that it's caught. Like, you'll intuitively know, oh, that's caught, and you'll do something. But now you're asking a robot to have that same kind of responsiveness, and we're not there as a field yet. And the third one that everybody, well, a subset of people in homes want is they want it to do their homework, which we could do, but we probably shouldn't. So as I was mentioning with the dishwasher, manipulation is a particularly hard problem in robotics. Amazon put up a big prize, what they call the Amazon Picking Challenge, which is basically one of those trays, carts full of stuff comes, and you want a robot arm to reach in and pack the box instead of having a person pack the box. So that's another level of automation that they're looking for. And that turns out to be really, really difficult. If you look at consumer packaged goods across the whole range of them, they come in lots of shapes and sizes. They're not always in neat boxes. The boxes aren't always easy to grab. And so, and people try everything. I was in University of Tokyo where they had a system for competing with this challenge, and they had built a gripper that was like, it was a gripper. It had like 3 different ways you could grab. It had a suction. So if there's a box, they would turn on the suction and just pick it up that way. And if there was something else, they would try to grab it. And they just had all these different mechanical affordances to try to make that easy. And then you still have the perception problem. You have to recognize what it is you're trying to pick up and how its pose is, and then manage to grab it the right way. It's an enormously difficult problem and unsolved at this point. The business model, so again, for the use case, what do you charge? And finally, there actually is a challenge of shortage of skilled robotics people. So robotics at this moment, especially in Silicon Valley, is a very hot market. So if anybody's students in the room are thinking about careers, I suggest that this is something that you might want to look at if you're interested. It's extremely interesting because it's cross-disciplinary. And just as an example of that, how many people in here are computer science focused? Electrical engineers? A couple. So in the electrical engineers, are you more sort of analog, or you software? Do you do like low-level software stuff? Both? Okay. So what I discovered in managing robotics teams is that, and I'm a computer scientist by training, so what I learned was that there's this thing called a waterfall model, and that it's totally wrong. And everything should be cycles, and today we have agile programming, and everything happens really quickly, and so on and so forth. That waterfall model that's totally wrong is what they use in mechanical engineering, and for very good reasons. I mean, it's not that they don't want to iterate, it's that when you go to build a product, if you don't do a product requirements document and then do the design and then pass the design off, you end up building something, some physical thing, and it's not so easy to iterate. It's not so easy to go back to, the factory in Taiwan that made that part and say, oh, I just want you to tweak it a little bit. I mean, you can, but it's expensive. And so the industry is getting faster at that, and cycles are getting better. Cycle times are getting better, but it is a big difference between hardware and software. And just as one example of, what roboticists deal with is that you understand both the mechanical side and the CS side, and then you have the electrical side. It's kind of in the middle. There's firmware that you can iterate quickly on, but there's also, and board spins are actually getting fast enough that it's often not as much of an issue, but it can be.
Is 3D printing and computerized?
3D printing helps, but 3D printing is not perfect. So not everything, I mean, if you were making an entirely plastic thing and the type of plastic didn't matter, then 3D printing would be okay. Or if you had a very expensive 3D printer and you can print metal, and printed metal would be just as good as bent metal, then you probably could also. But so it's not that you can't make something quickly and iterate on it, because you absolutely can. 3D printing, and for us, actually,
Actually, Steve, you should invite Cal to your offices.
Yeah?
I recommend
Okay.
you invite him.
Calm down. I'll actually show you. So this was a picture that I showed also the last talk. But other than the trash can, which is not a robot, these were the robots. I challenged our hardware team to say, look, let's do, and actually the whole team, let's do a prototype a month for 5 months, for the first 5 months that we existed as a company. So this was back in 2013. We started with, Roomba kind of bases that we could just buy off the shelf, and we started putting foam core mock-ups, and we put sensors on the top of the foam core. It wasn't perfect, but it was just basically form studies, but also functional studies. Can we make these things work? By the 5th month, we had this robot over here, actually by 4.5 months, and I said, well, we need to cover it somehow so that we can put it out in the field. Let's try spandex. That's my computer science approach to mechanical engineering. The spandex didn't work very well, didn't look very good, and the industrial designer, after just a moment, said, get rid of that. And we 3D printed the whole skins. So we were able to 3D print it. Now, you can almost, I don't know how close you can see, but there's some lines on there that are actually artifacts of the fact that we printed it on a little 3D printer. That's all we had. And we kind of glued it all to the frame. And then it actually, the current version of this, the last version of this prototype, we gave it to an auto body finisher and had them do Bondo and sanding and nice shiny paint, and it actually came out pretty well. So you can do a lot with 3D printing, and 3D printing plus, actually the frame is laser cut MDF. That combination turned out to be a really nice way to make, robots of about this scale. But on the next generation of hardware, we continued to 3D print the skins, and eventually that became a serious bottleneck to getting any kind of, each one took a long time. Each one took 3 or 4 weeks to finish, which, it's hard to scale up the business as you're doing that. So the last thing I want to talk about is the challenge of 24/7 autonomy, and that's where we've been focused on for the last 3.5 years. So Savioke, just as background, is a 3.5-year-old startup. Willow Garage ended in 2013, August. in September, we sat around a number of people who had been at Willow, sat around different people's dining room tables in coffee shops and so forth for about 2 or 3 weeks, trying to figure out whether we wanted to do something together as a startup next. And 7 of us decided, yeah, we're going to take the jump. And so we created Savioke, and our goal was, we knew that it was low-hanging fruit for us to build mobile robots in human spaces. But what is it actually going to take? Are people going to accept them? What does it take to make them go 24/7? We're going to learn a lot. And we focused on a use case of delivery, so guest room delivery in hotels, and I'll show you what that is. But before I get to that, this is the other way you can do robots in hotels. This is actually video that I took with my cell phone.
For today's hotel guest data, please say your name in full.
These are 2 robots at the front desk of a hotel called the
Thank
Henna
you for
Hotel
your
in Japan,
visitors.
in Osaka. It's
Your
a-
name and the room's card. On top of the fill in the phone number, please put us to the bottom of the post. Please press to proceed with the send to.
The funny thing about this is that robot, the one on the left, the one that looks like a woman, says Japanese only, so she only speaks Japanese. The dinosaur, of course, speaks English. Or what? And it was right before Christmas, and so the dinosaur was actually dressed up like a reindeer, and the woman was dressed up like Santa Claus or something. So it was a very surreal kind of experience. People, this hotel, attracts visitors as this is kind of a show. But the reality was, after I got done trying to check in with this thing, and doing what it said, the last thing it says is, please check in at the kiosk to your right. So you step over and check in on the kiosk. It's not actually checking me in, it's just there as a little bit of a show. There were a lot of technologies I admired this hotel for trying to put every kind of robot they could think of in and try to see how it works. Some of them I liked a lot. My favorite one was they had face recognition door locks. Not exactly a robot, but a really cool technology. You never forget your key. You come back and turn on, as long as it doesn't open for somebody else, which I only tested one other person that didn't open my door, so that was good. The one I liked the least was actually even creepier than these guys. It was a cute little robot that sat between the 2 beds in my hotel room. And when I walked in, it started jabbering to me in Japanese, saying basically, welcome to your room, I'm glad you're here, blah, blah, blah. And it talked for a little while, and then finally it shut up, and I was kind of freaked out, and I turned it around to face the wall and forgot about it until about 3 in the morning, when apparently I was talking in my sleep, and it said, "Nan desu ka?" It said, what? Wakarimasen, I don't understand. And I was like, who's in my room? It was very weird. I wish I had unplugged it. But when we set out for hotels, we weren't setting out to do a robotic experience so much as to do something that would help people and solve a real use case. So I showed you this already. So this is the robot that we built, and this is an example. It's running at a number of hotels in the area here, including the Crown Plaza and the Aloft. But this is Relay. It's also, at this hotel, they call it Dash. We let the hotel give it their own name, and they think of it as a team member. And I've been to hotels where it was broken for a day for various, like somebody put water in it. I can tell you that story too. And when it was out, the staff say things like, "It's in the hospital." It's just not. It's just in the back room waiting to get fixed. But it does, navigation down the hallway was something that we had been able to do at Willow Garage. This is one of the things we had to do was phone system integration. So how do you answer, what happens when you get to the door? Well, we call the room, and then we actually watch the door for the door to open. And when the door opens, we open the lid in response, which turns out to be a pretty cool UI thing. We added a whole bunch of interactions after that just because people want more robot time. So there's all this delay and a survey, and then it leaves. And if you caught that, if you give it 5 stars, it's a little Easter egg. It does a little happy dance for you. Yay, we call it the shimmy. But the door interaction turns out to be the key to this in terms of why people like it. First of all, it comes to your door much faster than a person, right? It doesn't move any faster than a person, so how does it get there faster? The insight is, if you have a robot sitting by the front desk and somebody calls the front desk and they walk over to the robot and they put it in and say, go, nobody has a problem with that. That seems totally natural. There's a robot waiting to serve me, right? If you have a person standing by the front desk waiting to do a delivery, the hotel manager almost certainly is saying, why don't you go do something useful? Go wash the windows. We don't really let people stand around except outside the Buckingham Palace. But in general, we don't like people just standing around. We want people to be working and productive, especially in this country. But it's okay for robots. And so as a result, you don't have to summon somebody to come and take the delivery. You don't have to wait till you're free. You just put it in the robot and it goes. And I've personally experienced a 3-minute delivery at a hotel where I was on the 4th floor, and I just called and asked for something. And 30 seconds after I called, the robot was in motion because I could check. And 3 minutes after I called, my phone rang. And I was like, wow, that's really good. And I didn't tell them it was me, like, that was my company. Although they might have suspected after I ordered toothpaste 3 times in a row. I don't have, sorry about that. This is the Len Kleinrock video I mentioned earlier. This is kind of the door experience.
Well, hello. What have you got for me? Well, thank you. Candies. Candies for everybody.
Truffles.
Truffles. Truffs. All set. I removed my items. Oh, my stay is terrific.
So there's
Really like
training that, in his case, we actually had to do training
You heading
because
home already?
he saw the robot and he
But
started
you
talking
don't
to it and
need
asking
me
it to do
now.
things and treating it like it was a dog.
Bye.
And it didn't
Adios,
respond.
amigos.
And he didn't realize he was supposed to touch the screen. The cool thing about this
Bye-bye.
door interaction is that even if you totally don't get it, when you open your door, it opens its lid and it says, here's your stuff. And you had ordered something 5 minutes ago, and so you always reach in and get it. Like, we've never had anybody fail to work it. They might not do the survey. They might just close the door on it, or they might talk to it and it doesn't respond, but they got their stuff, which was the whole point. And it times out. If you shut the door or whatever, it'll go away. And so handling that 24/7 and all the cases, we went from, when we first tried it, we were about 70% of the time successfully doing deliveries. Today we're 99% of the time. So, you can engineer through those things and really get it up to a level where it's usable. And you can go visit, we're at Stanford, so you could go across the Dunbarton Bridge. There's an aloft there. You could see one. In Cupertino, there's an aloft across from Apple. You can see one, and that Crown Plaza you saw is in Milpitas. There's about 6 or 7 in the Bay Area now. Yeah.
Still the case that you get the double door open, where they open the door, see it, shut the door, get their camera, come back and open the door again?
That has happened. Yeah, that was. It happens in lots of ways that people want selfies. We've had videos of this go viral and get like 1 million hits on YouTube. For record, I've never gotten any Willow Garage video, including that beer thing, to get 1 million hits on YouTube. So it's pretty cool. It has to be somebody who's not associated, who's just doing it because it's cool and maybe has a bunch of followers. But yeah, you see people hanging out their door as it comes down the hall or chasing it. The one thing that's sometimes frustrating people, they want to put their camera here and have it come right up to them, but of course it doesn't. It goes around them, and they're like, ah. And we actually tried we call a Mingle application. In Singapore, there's an airport called the Changi Airport. It's the only airport in Singapore. All the flights are international, it turns out. And they wanted to do mingling with guests. And so when we first tried it, we had this horrible problem, which is the robot would see, like, we would have it detect where the person, like, oh, there's a person there, so I'm going to go up and try to interact with them. And the person would see the robot coming. And what we had done was we had figured out where the person was, and we said, go to that spot. And then the person walks to the robot, and the robot goes around them and goes to that spot and faces that way. Like, that's not what you want. Robotics is frustrating because they're extremely literal in what you tell them to do.
We all know that from watching Star Trek 30 years ago.
Yeah. In the PR2 case, we had this problem when we put arms on it. And as soon as we had the base running, before the arms were attached, we had the robot navigating all over, and then we put arms on it, and it wouldn't go. And why wouldn't it go? It won't go because there's an obstacle right in front of it. And so you had to teach it about itself and do self-filtering. Literally, there's like a self-filtering thing that takes out the arms. And you're like, great, okay, I figured it out, now I can go. And then let's have it pick up a Coke can. It won't go. Why not? The arm's filtered out, but the Coke can isn't, and there's something in front of me, so I won't go. It's really kind of insidious. Eventually, we wrote this program for the PR2 that said tuck arms. Just put it here so that they're out of view of the sensors, which was great, and the robot would go around like this. And we took it to the tech museum, and this kid says, "Why is it angry?" It's not angry. It's just getting its arms out of the way. Yeah, there's a lot. Yeah, exactly. So just as where we're going as a company, we've built this robot that navigates very successfully in indoor spaces. Hotels turn out to be a kind of easy first case. Think about in a hotel walking from the front desk to a room. The only barrier you encounter is the elevator. We automate the elevator so we can talk to it, and then we manage to make that trip very reliably. In other spaces, like think about your home, you have stairs and things in the way, or you have security doors. So think about like here, getting into a room, like navigating it into here is not something that our robot could do today, because although I can get down this ramp, it can't automate the door back there. So somebody's going to have to help it, right? So doors are barriers, stairs are barriers, and nevertheless, there's a lot of spaces that are commercial spaces that we can handle. And so we've been looking indoors at hospitals, at logistics applications. And it turns out that once you can navigate reliably and repeatably, and somebody can put something in, it works very well. What's unique about this robot is it's designed from the ground up for safety. So you can put it around people without worrying about it. You don't have to require steel-toed shoes or put robot lanes on the floor or anything like that. You don't have to put beacons in because it's using its own onboard sensors to know where it is. And one of the things the hotels told us early on was, we're not going to send anything more than a toothbrush if you don't lock the lid. And we wanted them to send valuable stuff, and so we have a locking lid as well as automatically opening and closing. That allows you to do chain of custody applications, because once you have a locking lid, you can control who can open it, who can close it, how you open it. So in the hotel room, the security system is the door. So we basically leverage the hotel door. In a hotel room, only you can open that door as a guest or a staff member. And that's who should be allowed to open the robot, either a guest or a staff member. And so the chain of custody works very well. In a factory situation or a logistics application, you might have the recipient type in a PIN code, or you might have them badge with an RFID. And we've been playing with all of those different things as a way to kind of make this a general technology. So with that, did I run out of time for questions? Or they came along the way, but I'll take any questions, yeah.
Yeah, thanks for good talk. Most of the robot you mentioned here were for indoor. Can you mention something for natural hazard? Like if there's an earthquake or beach, the robot go there to save.
Yeah, so this is the other thing that I've learned about robotics is that you have to always start with the use case and the assumptions, and then sometimes it'll work more generally. But robots working after an earthquake, your ADA assumptions are violated or potentially violated. And so this is not a disaster recovery robot. There's people, Carnegie Mellon has a whole group that design robots to go in mines or into really hazardous situations. You optimize for different things, right? Once there's been an earthquake and a disaster, you don't really care about scuffing the floor anymore. You can put a tracked robot and you can get over a lot of stuff. But in a hotel, if we put tracks on this so that it could get over all the bumps, it wouldn't be very friendly, and it would be hard on the carpets and the stairs and so forth. So the requirements really do change dramatically around the hardware. This is one of the reasons that people argue for humanoid robots, is because, well, humans can do this, so robots can do it too. I don't think you strictly need humanoids, but you can, and people have made robots that are shaped like spiders, but they're really creepy, just like real spiders. And so you don't necessarily want them, climbing down your hotel corridors. You can imagine a spider going down the hotel corridor to do a delivery. It wouldn't get the same kind of reaction on TripAdvisor as we do.
Yeah.
Yes?
So you mentioned that one of the big breakthroughs for the field in the last few years was the Connect sensor.
Uh-huh.
And so I was wondering how much a much larger sort of supply chain expansion has happened with cell phones for cameras and all kinds of stuff. Are you guys able to take advantage of some of that? Because it's like at a different scale altogether.
Yeah, some of that. So I sometimes refer to robotics today as the poor stepchild of every other industry, right? We get video game sensors, we get cell phone sensors, we can get accelerometers that have been cost reduced for cell phones, or for even now for drones, they're starting to be enough volume that's kind of interesting. But it's, volume drives cost down, especially in electronics. Apple bought PrimeSense, which was the technology behind the Kinect, which actually threw robotics in a tizzy for a little while. Like, we at that time cached enough to build our first bunch of robots, and we're now sort of finishing those up. Fortunately, in the meantime, Intel's come out with RealSense, and we'll use that as a replacement. But and there's some other replacements out there as well. But yeah, supply chain is challenging, and when you can leverage cell phones, it's not like Apple's likely to sell the sensors or let robotics people buy those sensors, but it will drive the cost down. Apple would be able to build a low cost 3D camera, but the field is moving really fast. So people are, LiDAR. We talked about LiDAR, which is a laser rangefinder that's a planar laser. There's a lot of people trying to do a solid state or a very low cost LiDAR. LiDAR is typically around $2,000 today. But people are talking about a $50 LiDAR or $100 LiDAR, which is a game changer for small, inexpensive robots. It doesn't solve everything, though. When you look at the challenge of putting robots into the environment, even the robot itself, the whole bill of materials, is only a piece of the cost, right? We're doing robot as a service, which means we're doing monitoring, because it would not be okay if you sent a delivery to a guest and it didn't get there, right? I mean, that's a huge customer relations problem for the hotel. So if I had a 3% failure rate where the deliveries weren't getting to the guests, the hotel staff would not like the robot. They would not want to keep using it because they'd always have to be checking. What we've done is put a monitoring system in place, so there's a cloud monitor and there's a call center. And so as a result, if for some reason it's not going to get there, the front desk is going to get a call and be told that delivery hasn't happened yet, so you better, you may want to do something about it. And it's a pain for them, but at least the guest is happy, unless the guest was counting on the robot, in which case maybe they can reset it, right? By the way, the failure cases are not always our fault. Kind of failure cases, we mentioned drunk people knocking over the robot. It's only happened a couple times, but people getting in the way of the robot for a long time definitely can slow us down. People pushing the robot off the elevator on the wrong floor is annoying. Initially, it was just confusing. Actually, we get them back because when it gets to the floor the robot was going to, it's still in wireless connection with the elevator, so it's holding the door until it can get out. And it's confused, it ain't getting out, so they're just waiting. So it sort of gets its revenge, but we've actually fixed that. That was just accidental. There's somebody asked me, well, what happens if people don't let the robot out of the elevator? And that's the same thing. The robot's holding the door. So you can block it all you want. You're not going anywhere. And the robot has more patience than you do, I guarantee it. Yeah.
You mentioned that the robot can actually get up and do a delivery in somebody's room more quickly than a human. I would think that a couple of the factors are that a human has to get to the elevator before it can summon it. So there's a serial process there, whereas a robot linked into the elevator control electronics might be able to do.
We don't actually use that. We could use that, but we don't use that. That's an optimization that would save you 30 seconds or something on average. And so we could even do better. But it turns out the difference between a robot delivery time and a human delivery time is like 5 minutes versus 25 minutes. And that waiting time for the elevator doesn't explain that difference.
Why is
right?
it so much?
Because
walking much faster or driving
no,
much faster?
it's because the robots, when you want to send the delivery, like I'm the front desk guy, so I want to send a delivery, I put it in the robot and it goes. And now it's on its way immediately. If I don't have that, I'm still here. I got a line of people that are checking in. And so what I do is I pick up the phone or my cell phone and I call somebody to come do this delivery. And what's that person doing right now? That person's washing the windows on the third floor, and they can't just come right immediately. They got to take the stuff, the window washing stuff, and they got to stow it someplace, and then they can come down. And so they'll batch it, right? And they'll do it when they can do it. And so, I mean, it's possible to get a human delivery in, I mean, you could get it in a minute, right? If you got a guy who was willing to race up the stairs, or, you know, just time of the elevator, but they don't do that. In practice, it takes a long time.
So you're saying the robot is already enough much faster than a human that people are happy with that? But I would think there would be some optimizations, like if you wanted to pre-summon an elevator, if you wanted to pre-call the room to say
But that's
robots.
that's like AI games cheating.
No, we don't mind. I don't mind cheating. I don't have a problem with that.
I'm waiting outside your door. Would you like a box of cookies?
And even jogging down the, you know, when I'm in a hotel, 90% of the time the halls are all clear sailing, no other people. You stress safety, but that's only an issue, I presume, when there are humans around. And
Well, but
this
you
robot
know,
right now could zip down the hall quite a bit faster if you wanted to give it bigger engines.
yeah, we could certainly. I mean, you could imagine it running at the speed of a remote control car. But you also have to think. I look down the hallway. There's nobody there. I'm flying down the hallway, and somebody walks out of their door, and bam! You know, that's not good from the hotel's point of view.
But hotels actually don't care about this. They care about guest satisfaction and costs.
Yeah. So let's talk about guest satisfaction, because that's a big one, right? You're in your room. You just arrived. It's 10:30 at night. You decide that you want a snack, and the first issue with and it's only the first issue is how long is it going to take for the snack to get here? Because I don't want to stay up till midnight or even till 10 till 11 o'clock. I want this thing to come fast. So the first, speed matters. Second one is who's going to bring it, and are they going to be having their hand out? And what currency are they expecting, and how much should I tip them for this snack? That ends up being a barrier. And I just got undressed, and somebody's coming to my door. I have to get dressed again, or am I okay with? I mean, this woman's in her robe, but that's a model. You know, some people will and some people won't, and I can tell you from early testing that some people will choose to open the door without any clothes on. But those are the rare cases, and we now blur the video looking into the room because we can and because we should. But those are all issues. Those are all barriers why people may not come. So you have a robot coming faster, no tip, no getting dressed for it, no awkward interaction, and I'm not bothering anybody. And those are the reasons that people think, oh, this is great.
The hotels advertise, we have robots, therefore you're getting this benefit, or people just discover. Because if you don't know that your delivery is going to come in 5 minutes, you think it's just like every other hotel in the world, and so you don't do it.
So we find this. If the hotel markets the robot to the guest, they use it more, and then the satisfaction correlates. So a robot sitting in the lobby doesn't affect guest satisfaction very much. A robot that does deliveries will get people to write about it on TripAdvisor, and will actually be measurable bump in those satisfaction scores. So the Aloft in Cupertino and the Crown Plaza, they all have marketing materials. They have a card in the room that says you can get a delivery from a robot. What it's a menu, what you can get, and they have on the screens. If the Aloft, they have everything everywhere. So they do a lot of internal marketing to get you to use it and recognize that there's this value. Yeah. Yeah.
Two questions. The first one is, I guess, going off of what was just previously said, how difficult was it convincing a hotel for you to trial the first iteration of this idea?
Not that difficult. So we asked, and I didn't have any contacts with hotels when we started, and a VC gave me this advice. Actually, Manu Kumar from K9, who used to be at Stanford, said, well, what you need to do is get more hotel contacts, and I don't have any, but here's what you can do, social engineering. Go to the front desk and ask for the manager. They always come out. And that was true. And so we end up it turned out it's better to call ahead. But the manager will always talk to you. And we talked to 20 managers of hotels in the area, and 14 of them were positive on the idea. A couple of them, one of them said, you know, I want to be your playground, to your lab to basically experiment. So you can muck with my elevators and everything, and it's fine. But he wasn't willing to pay anything. Another one said it was this was the Aloft. They called Starwood headquarters and talked to the brand manager, and that guy flew out and talked to us. And that's when we knew we were onto something. And then we did the technical side, and they really played up the marketing side, which I hadn't understood how important it is to have those collaterals in the room, but they got it, and so they put those things in from the launch, and it made a big difference.
Are you talking about the Swiss hotel school we gave you?
I don't know if we ever connected.
Because they did see one of your robots in Singapore, I guess.
Yeah, so we
They
have
were
one.
interested.
Okay, yeah, we have one there now in Singapore and finally New York. Yes.
If this is fast enough and doesn't involve paying tips, this would seem to be a replacement for mini bars and lots of things that would be in the rooms already. If you could order something on demand and have it arrive when you want it. The advantage of a mini bar is immediate gratification and sending up.
Yeah, so it turns out that in the U.S., mini bars are mostly gone because the labor cost of stocking them and the issue about how old is that Snickers candy bar that's in there and keeping track of the inventory and stuff, and the fact that a lot of people will deny that they took something from the mini bar, try to fool it or whatever. They tried these sensor things, but there was just, in the end, most hotels have gotten rid of mini bars because they weren't very cost effective. We actually pitched this partly as you can bring back that service. The one thing that mini bars have that we don't have is the bar. They have liquor, and sending liquor is still challenging because depending on your local law, you got to be checking for IDs. And whether you believe that the robot can reliably check for IDs we haven't solved that problem too much. But yeah, you had a second. Yeah, go ahead.
Yeah, you've also talked about potentially working in hospitals in the future. It sounds like you've explored that a bit more. Could you talk about it some more and just like what potential ideas you thought about?
Yeah, so I mean, if you look at delivery robots and you say, where do they go? You look at where is stuff moving, and hospitals have an unusually high amount of stuff moving because you've got samples, you've got medicines, you've got all kinds of supplies, many more supplies than you have in a typical space. This would have been a fantastic product when there were mini bars. This would have been a fantastic product back in the 90s when we still had paper mail, memos and things. It's less interesting. In a lot of human spaces, bits are moving instead of paper and supplies these days. But hospitals, that's not the case. So hospitals are interesting for that case. And so we can do deliveries there. Hospitals have a problem that they work on pretty small margins. But they've also, the legal framework and the healthcare, last night's discussion or the last week in politics around healthcare and the Affordable Health Care Act and so forth, is actually, things may be changing, but the way things stand at the moment from a legal point of view is that if you're in a hospital and you're diagnosed with some disease, you go home and it recurs and you come back to the hospital has to cover that cost of the readmittance cost, right? That they want to make sure that the payers, which is the government and the insurance companies, want to make sure that the hospital is responsible for the quality, so they don't send you home sick. If one of the things you need to do to get better is take medicine, and they send you home without the medicine, your readmittance rate is much, much higher than if they send you home with the medicine, because you may not bother to go to Walgreens or whatever and get your medicine filled. So they really want you to take your medicine when you go out. And today what happens is you go up to the pharmacy, if you bother to go up to the pharmacy on your way out the door, but you may not. So if you can actually bring that to the room and have the nurse, before they check you out, hand you your medicine, that's a big win. But it's labor intensive to have somebody shuttling that stuff all around, and the robot basically takes off almost all the cost off of moving the medicines to where they need to go in a secure way. So that's one of the ways that we're using Relay. There's other robots in hospitals and have been for a long time where Relay is kind of a FedEx delivery truck within indoors, right? The Athon Tug has been around since 2002. It's like the freight train. So you may have seen them if you've been in any of the local hospitals. They have these like 500-pound loads, and they're going along with towels or sometimes with food, and they go beep, beep, beep as they go down the hallway because they're big. So for safety, they have to warn you that they're coming. So they're kind of two different approaches. It would be very inefficient to use an Athon Tug to deliver, one vial of medicine to somebody in a room, and it wouldn't work for Relay to take all the linens that are needed on a ward, we'd be making a lot of trips, right? So they're just different technologies. Yeah.
What's the cost of one of these things compared to a salary for a delivery person?
So they come in at less than the cost of a person, but they're 24/7. So depending on how you use it, the effective cost can be as low as like $2 an hour. But again, they don't do everything that a person does. So, and they do some things that a person doesn't do. So they're willing to sit idle, so they have infinite patience. They can audit every single trip, so you can have a record, chain of custody record if you're sending things. That's much harder to enforce with a human. There's no there's no way that this thing's ever going to steal from you, or or cause harm, or go on an unauthorized break. I mean, it could break, but it doesn't go on an unauthorized break except for downtime.
Actually, stealing from you isn't quite that confident. Somebody could hack into your system and direct it to the wrong door.
Maybe, yeah. I mean, it's a lot hard. Yes. Well, if this is actually a good question. Is it low value or high value stuff? For high value stuff, we have to provide a higher defense against hacking, but it's still arguably very different than I have a guy with a cart pushing it down and things quote unquote fall off the cart. Right. That's not going to happen with a locked bin when somebody's signing for it at the other side digitally.
John, I should point out to you, if you go into the restrooms in the Microsoft facilities, they have free toothbrushes for the employees.
Yeah, put it in the back.
Do you think you can move this into a mobile vending machine where you can swipe your card?
Yeah, so what's missing from this first version is that it only has one compartment. So I can vend one thing. Or I could do newspapers, because assuming you're only going to take one, but again, newspapers is another 20th century thing that paper newspapers is not such a good one to deliver. But certainly it's possible to design a different locking mechanism, different top for it. Yeah, it's empty halfway, all the way, more than halfway down. So it's a pretty deep bin. So we could have locking drawers. We can definitely do something like a mobile vending machine if that's the right thing. The cool thing about this is that although it takes somebody to put something in, what they put in can be something that they recently cooked. Can be like the hotel that the loft where we started always does ice cream. They've always done ice cream, and because it's only a 5-minute trip, we don't have to cool it. We have it gently warmed by an i7. And then down in LA, one of the hotels has Starbucks in the lobby. They send Starbucks in it. So it's not that, it's like a vending machine. It's a different experience than a vending machine, potentially. But it's an interesting idea. Yeah. Yes?
So you mentioned that in the beginning that ROS is a really great platform for all these companies introducing these robots. But then again, the code is not as hardened. So extrapolating to the future, how do you see ROS evolving to meet the demands of a commercial industry?
So ROS, the Robot Operating System, is now supported by the Open Source Robotics Foundation. And the Open Source Robotics Foundation now has a subsidiary called the Open Source Robotics Corporation, which is a for-profit. So it's very much like the Mozilla nonprofit for-profit model. That means that you can contract with the corporation part to harden something for you, or you can get something for free from the nonprofit part. Also, there's a project called ROS Industrial, which is taking the robot operating system and hardening it for use with industrial robots, where that's a much more mature industry. The bar is higher in terms of what people expect, and the safety matters a lot. And the reliability, right? Because if you're in a car factory and the robot breaks, if you're using ROS and the robot would break, the whole line sometimes stops. The notion of an assembly line, by the way, is also changing with robotics. It can be much more flexible, but when you have an assembly line, you have robots on it. If they break, it's a big problem. It's millions of dollars an hour. So ROS Industrial is trying to harden ROS for those applications. And the Open Source Robotics Foundation is continuing to improve and harden ROS for generic. And you could contract with people to do better.
So would there be flow back into the open source?
Yeah, there is. So there's two things that can flow into open source. One, I mean, you can download ROS and you can create a new ROS package and you can submit it. so everybody can contribute stuff. Getting the Open Source Robotics Foundation to agree to support what you wrote is a little more challenging because they can't support everything that all graduate students do in robotics. You know, everybody, I could do the project here, it's yours, and they're stuck with this code. So they look at what's needed and what people are asking for. Then they look at all the samples of solutions and they pick one and they decide to support it and put it out, assuming the licensing is right. But if you find a bug in ROS and you submit it back, they'll also add that to the next release. They'll validate the patch and then put it in. So it is a robust, like any other open source ecosystem, with the nice thing that there's this, first of all, big investment that we put in at the beginning, and then a company that's maintaining it over time. And they've been around for 4 years now, 4.5 years. Yeah.
In terms of the input sensors, you mentioned early systems using an array of sonar detectors. You've mentioned LiDAR as being a way of tracking walls and such. You've mentioned the Xbox Connect, I guess, as being a structured, and the new Intel system. This would seem to be an application that just cries out for machine vision cameras. Replacement camera for my iPhone is $4. Compute power is free, more or less. I can't think of a better structured environment. Look down that hallway. It's just filled with visible cues of texture on the floor. You know the floor is flat. You know the walls are vertical. You know where the edges are. It's all obvious. You could look up and see the ceiling and see the lighting fixtures. You could easily pick out lighting fixtures on the walls. What's your current attitude on just rolling your own machine vision system that's able to look down a hallway and pick out cues that it knows should be there and localize them? If there's a tray of food on the floor, that's not what it's supposed to look like. If there's a person in the hallway, he's not the right color of what the wall should be. I would think that would be a
you make it sound so easy. I said you make it sound so easy. So this has been a holy grail of computer vision, especially the one camera, for decades, right? And it's getting better. So, and especially with drones, if you fly a camera through space and you look at visual flow, you can estimate your motion through the space. But the stuff that you said about, I can assume it's a flat floor. Well, you can't actually assume it's a flat floor, right?
You can assume that the floor is the same angle it was at the last time it wasn't that floor.
I could go through and try to look at everything, but when somebody spills coffee on the floor and there's a spot, now I can't go, right? Because it doesn't look the same as it was, and I'm depending on that.
There's a better way. Just connect this thing through the network to a machine learning system in Google or so that's better, because you don't have to do all the onboard processing here. Right. Now there are ways, there's these GANs and whatnot, there's next week's talk coming up. There are ways to detect aberrations. So this stuff is getting really good, but little companies, I've done a few of these, we don't have the resources to keep up with.
Well, that's part of it. The other thing is, when you depend on the cloud for your motion in the world, when you got a glitch with the network, whatever it is,
Once.
No, I got robots in dozens of hotels in different places around, right?
There's many ways around.
Okay, the problem's solved.
You said that the holy grail has been single camera, find everything, but cameras are so cheap and compute power is so cheap that, no, I would advise putting a number of cameras. If you're going to put on an Xbox Connect, you're only going to have one of those. I presume that's what the slot is, towards the bottom, where you're looking out through that slot or something.
We actually put two on.
Okay, but with cameras, you could have a dozen, some looking up, some looking forward.
And there's no reason that the hallway can't have cameras too.
Well, that's another. So, yeah, it turns out that the cameras in the hallway are cheap. Running the wires to power them is not cheap, and getting them installed is not cheap. So we've spent a lot of time, as we put robots in the world, dealing with like the elevator companies and what it takes to get integrated with that system, dealing with the phone system in the hotel and what it takes to get integrated with that system. It's all doable, right? But doing it at scale is not so easy. And so every time I have to put something cameras in the hallway, I'm thinking, oh my God, this is going to be hard. And one of the things we learned is, like, how often do you think an average hotel, updates their Wi-Fi?
They haven't yet.
No, it's not true. About every 3 years is what my estimate, right? Which means a third of the hotels that I'm in are updating their Wi-Fi every year. And when they update their Wi-Fi, they always forget that there's a robot. And that's depending on, because you have, like, it's designed for people to use. And then you have a few systems that are allowed to use it using, sort of whitelisted systems. And the robot becomes one of those whitelisted systems. And when they bring in a new networking company, they forget to whitelist the robot, and the robot breaks. And they call us up and they say, the robot's not working. Like, oh, why isn't the robot working? Oh, it turns out we changed our network. Oops, we forgot to tell you. Okay, so now we have to send somebody or integrate, work through that, tell the robot this new network IP address or whatever. So every time we depend on the infrastructure is a failure opportunity for us. And we don't control the infrastructure, so it becomes a nightmare. So I want to do what I can on the robot, not depending on the Wi-Fi infrastructure. I believe that wireless will come, but I had these same debates with Scott Hassan 15 years ago about, we just assume that we're always connected to the network. That's coming any day now, right? Well, that was 15 years ago. It's coming, sure. At some point, we're all going to be connected all the time, and there's not going to be you're never going to be in an elevator, let's say hypothetically, where it's a Faraday cage when the doors close. It's a real problem. And it's not a problem in every elevator. Some of them are glass. But it's a problem in some, and so we're doing this kind of empirically. We go out and we put a robot. Somebody calls and says we want a robot on our property. We put the robot in and we work through all the problems. And then the next time it's a little bit easier, but the next time they have some new problem. And by now we're starting to get some easy installs, but everyone is challenging.
So how long does it take you to install a robot?
Once you get the elevator guys to come out, it's only a few days. And we can get it down to, I'm sure we could get it down to under a day, and maybe below that. But the business model that we have right now, where we're doing installs, and part of what we do is not just make the robot work, part of it is training the staff. So we have to send somebody out today because it's a new technology. I think, 5 years from now, if I get invited back, I may be talking about a different thing about how we do this completely automatically, but we're not there yet.
So is Rev 2 going to be able to carry pizza?
Yeah.
Well, cook it and root, I presume.
Yeah. Rev 2 is going to be cool.
You're going to say experimentate?
I like that idea.
Yeah. No, I don't think so. It does look like a Dalek, but not on purpose.
So if you built, lots and lots of them, could you get the price down a whole lot?
Yeah, of course.
Where's the good point?
How low can you go? It's a good question. I think it depends on how you solve the sensing problem. So we kind of break down the problem of navigation indoor into obstacle avoidance, for which 3D is a really good solution. Localization, so how do you know where you are reliably? And then you still need to be able to get over the bumps and stuff, right? You still have to make something that's a decent size. You can't send deliveries in hotels in Roombas. Right? Just too, like, ergonomically, it's not good, and people will trip over them. So there's certain size requirements, and it takes a certain amount to make things this size. Could we do this? Ultimately, could we make this for a couple $1,000s? Probably, but it'll be a while before we get to that point.
I don't know that you went into much detail. There was a question about what this costs in terms of defrayed dollars per hour minimum wage. What are your materials costs for building that unit right there, and how does that break down between, say, raw mechanics versus compute power versus?
I think it's a great question
sensors?
for over dinner.
Yeah.
Okay.
Let's
Or after the camera.
let's take off the camera so we can.
Kind of tremors that he would naturally have in his hand, because the system can filter that out. It allows the surgeon to rest. If you think about doing a 7 or 8 hour surgery and you're trying to hold on to some device inside of somebody, especially if it's laparoscopic, you have this very expensive thing. And what do you do when you need to scratch your nose? You tell the nurse. What do you do when you need to rest your arms? You really can't. But with this system, you can basically clutch. System stays put. You can shake your hands out. You can go on and continue the surgery after 4 hours. So powerful, but remote controlled, and there's no autonomy. And then you have mobile remote controlled robots, and this one is most popular in the bomb disposal robots that came out of the most recent wars in the Mideast. Basically, in order to deal with uncertain radio waves and avoid jamming, they'll typically run a fiber optic cable out, and so the robot really is just a tethered remote control, just like I had when I was a kid, which I figured out as I was coming in here is about how long this seminar has been around, since I was a kid. But it's a very, very sophisticated version of that, and obviously ruggedized. And then finally, you have both autonomous and mobile, and that's really why I want to talk. Autonomous and mobile, though, still begs a question. There's still a way to break that down. So I put the Google car here as an example of, first of all, I don't know if we all agree that that's a robot, but I would assert that that's a robot. It's got sensing and actuation, and it moves around the world. And even though it doesn't look humanoid, that's not, in my view, a requirement for robotics. As a matter of fact, none of these look humanoid, and I argued that they're all robots. But the question is, where does it have to go? So that car isn't going to do very well in this canyon, right? But you've probably seen videos, I should have put one in here, of Boston Dynamics robots, the big dog that can basically run on this kind of terrain. So people are working on robots that can go here. And drones, of course, can go here, which are mobile robots of a different sort. They're not on the ground. But this is still challenging. It's still expensive. You can't go to the store or go on Amazon and buy a robot that's going to navigate this terrain. Roads is a little bit easier, right? Obviously you get that flat. Roads have this problem that there's other vehicles on them that are going at relatively high speeds. And yet we're able to start figuring out how to do that. You know that there's autonomous vehicles. Autonomous trucks are now allowed in Nevada. We've got the ability to test autonomous cars with human safety drivers on the roads around here, and I'm sure you've probably seen them. Obviously, major work on this came out in 2005 out of Stanford with Sebastian Thrun's work and winning the DARPA Grand Challenge, and later 2007 the DARPA Urban Challenge. So mobile and actually every Thank you. And yeah, this was not a long planned talk, but was the opportunity, and I said, wow, I didn't realize that there were repeat talks in 380, but I got invited to come back, so I said I'll take that opportunity. And so the title, Service Robots Are Here Too, is basically the same title I gave 2 years ago, except with the 2 at the end. And things have changed a lot. And one measure of success is that we were a startup. At that time, we were trying to raise Series A funding, and we're still here. So that's a good, thank you very much. Yeah, success happens. What? That'll be the next, well, no, let's hope that we stay around. So I want to start with just sort of what is a robot is always fun. If you want a really fun time, go to a robotics conference and ask somebody what a robot is and watch them squirm. And so I take a shot at it, maybe for fun. But what I find is if you try to say what's a robot, it's hard to answer. If you try to make a taxonomy, it's actually much easier to do. And so I like this taxonomy because it gives us 4 classes. So robots in factories are autonomous, meaning they do the same thing over and over and over again. Nobody's doing anything. There's a big switch on the wall. When it's turned on, the robots do their thing. And in the old days, it was just a precision motion. Today, it's getting to be more and more vision guided, and so there's more choices that they make. And this is kind of a classic industrial robot that I showed here, which is a welding robot. But if you step back and say, well, where else are robots used? You have sorting robots, and you have robots that will take things off a conveyor belt with an image recognition system, figuring out what's there, what the pose is, and then grabbing it properly and putting it into the right pose. And so you can see some robots working really fast and doing things. These are all constrained environments. You see robots doing things in factories, but almost always behind cages, right? And that's changing today with Baxter, the Rethink Robotics, and with Universal Robots. So there's starting to be some robots that can be around people, industrial robots with arms, but that really is the exception. The vast majority of robots that are out there are inside of a safety cage. You can have remote-controlled robots, and the most classic example of this is the Intuitive Surgical Da Vinci system, which is actually doing surgery on people. But there's almost zero autonomy in this. The only thing that they'll do autonomously is is pull out. Everything else is controlled by a surgeon. And so really this is a very sophisticated tool for a surgeon to do surgery that lets him overcome any very simple sensor that basically looks for a cliff and does a cliff detection and locks out the motor if it's not there. That works fine for Roomba because it weighs what, about 5 pounds or less, 1 pound. It's not very heavy. And so if it fell down the stairs, it's probably not going to kill you. Right? It's going to hurt, maybe bump off your leg or something, but it's not going to kill you. If you have a 100-pound robot rolling down the stairs, it's a different story. If you have a 300-pound robot, it's really scary. And so thinking about the safety implications of what could happen if, it turns out to be really important, and a space like I just showed here is a challenge.
Dean Kamen actually, with his iBot wheelchair, solve the stair problem?
So Dean Kamen built a wheeled robot that could go upstairs. Have you seen one in practice?
Yeah.
A lot? I mean, do you see it go around?
Not a whole lot. They're extremely expensive.
It's expensive and it's hard. It is possible to build a robot to go up and down stairs. The relatively less expensive ones tend to rip up the stairs. You can use tracks and you can get up and down stairs. But you still have to think, even in that case, whether you can get up and whether you leave this thing autonomous. It's fine if I can go up and down stairs, but what happens if I come sideways? I trip over. I mean, I have a lot of stories. I'll tell you one about these kind of unexpected things with robots out in the wild. We had a situation in the first hotel we were in where all of a sudden we started getting failures. Every time the robot would get to the 4th floor of the hotel, it would get stuck. I'm like, what's going on? And it's stuck in the elevator. Like, I say, what do you mean stuck in the elevator? I mean, actually, the wheel is stuck in the elevator gap, right? And how did that happen? Well, it turned out that the elevator guy came out to fix the elevator, left it a little bit out of whack so that it wasn't level. The robot comes out, pitches forward, sees the ground, thinks, oh, there's an obstacle, I better look for another path, turns, falls in. I couldn't have written a better test for putting the wheel into the elevator than what happened that day accidentally. Now, so you can just imagine that same, other things like that. If a robot's designed to go downstairs straight, you've got to ask what happens if it goes sideways and tumbles. Same safety question. In that case, what we did, by the way, is make the wheels wider so they can't fall into the gap. Then you solve that problem. Because you could try to solve it in software and say, I'm never going to go 90 degrees, but that ends up being a lot of special casing, and then you're adding other complexity and failure modes. Yeah. So this is where we're focusing on the kind of mobile autonomous, and those are the service robots I want to talk about. There certainly are other service robots. The other thing I'll say while I'm on this topic of what's a robot is just, robot is just a kind of technology, a kind of automation technology. The word robot comes from a Czech word that means like servant or slave. Your microwave is also your slave. Right? It does exactly what you tell it. It's right, and it even has sensing and actuation. You could argue that your microwave is kind of a robot. We don't think of it that way. We have, over the last 150 years, developed all kinds of technology, starting with, 150 years ago, starting with tractors in the internal combustion engine and things that basically make us more efficient and more efficient. Technology's been coming for a long time. Robots is a name for one class of technology. It's not the only thing. And I bring this up because there's all these conversations going on about, oh, now it's time for, like, robots are here and they're going to take all of our jobs and there's going to be nothing left for us to do anymore, right? And I think we're a long, long way from that. And I think that may be a false worry. Every time we get new technology, we end up creating more wealth, more jobs. The economy grows. There is displacement. We don't want to I don't want to underplay that, but it is something we could talk about later if you want. So this is just an example while we're on mobile robots. Here's a robot that's mapping a hotel room. And this is a tour de force of cinematography. Me holding my cell phone in one hand and the joystick to control the robot in the other. And the map that's getting created is up in the left. And the robot itself you can see it driving around from the cell phone perspective. But notice how the map, as it's driving around, is getting filled in. This is what's called SLAM, simultaneous localization and mapping. Actually, in this case, it's just mapping. There's no simultaneous. I mean, it is localizing, but it's not driving. It's not autonomous in this case. I'm driving it, and then when I'm finished, I'll have it autonomously navigate, but it won't be doing mapping anymore. The mapping is done. So we kind of separate those two phases. But what you can see is, as it goes along, the map basically expands and continues. And we do this practically today by just driving the robot with a joystick in a hotel, building the map, and then labeling the map with the locations you want to go to. I'll stop before it goes into my bathroom. Yes?
Is it using LiDAR right now, or is it just...
That one was actually using LiDAR, yes. And that's a typical way to do mapping. When I was at Stanford, a long time ago, but not as long as some of you have been here, I took a class in mobile robot navigation, and we had sonars. We had 16 sonars in a ring, which is like a LiDAR with a lot less points. Right? The LiDAR basically gives you a really nice picture of what you're seeing along the way, and almost looks like these are straight lines, when in reality they're just a bunch of points put together. Sorry. So what do we want? Why do we want robots? Why do we care about robots? As far as I know, every major car company has a lab doing autonomous robotics here in Silicon Valley now. So this is an area where things are really going fast. Are those service robots? I would say probably, right? Is a taxi a service? Is a limousine a service? Absolutely, right? So these are robots that are providing a service to people, and this is relatively new. You can't just call Uber and get an autonomous car today, but in the near future you will be able to. Sidewalks is another domain. Sidewalks is this one looks easy. Right? It's like, oh, that's just flat. You just build a little car and you drive it down there. And maybe you could on some sidewalks. And so there are companies coming out. As a matter of fact, the founder of Skype is now leading funding and leading a company that's doing these. It's called Starship, which is these little six-wheeled robots that are aimed to go down sidewalks. But the secret there is, they're going to do a site survey of the sidewalks before they commit to doing domain. So they're not doing arbitrary deliveries. They're saying, in your neighborhood where your sidewalks are in good shape, we'll do delivery, we'll map out everything, and we'll tell the robots, don't go down that street because the sidewalks look like this, right? And so it is possible to do what robots do, what mobile robots do. And finally, you have indoor spaces. And commercial buildings have a particularly nice feature, which is that we have the Americans with Disabilities Act in this country, which means that you have to have a ramp. We have a ramp here in this room that has stairs. So you have to have a ramp. There has to be a way for somebody in a wheelchair to get in pretty much anywhere in a commercial building. And that turns out to be a really nice benefit. Like curb cuts help bicyclists, this helps robots. And so that's what we're taking advantage of when we try to put robots into commercial buildings, and we've started with hotels. I'll say more about that later. But you still have these kind of places. And I've been now for the last 3 years putting robots into commercial buildings and not putting them into some commercial buildings. One of the issues is safety. So when you have a staircase, and these staircases are pretty modest, but when you have like the Grand Budapest, if you picture that one, you have a potential for harm if a robot would fall down the stairs. And so you have to pay a lot of attention as a product designer to say, what are we going to do to make sure that we've got safety covered? And it's not enough to say I have a keep out zone, because if you believe that your navigation system is 100% perfect, then sure, you put a mark on the map and you keep it out. But if you believe that there's some chance of failure there, you better make sure you've got a way to detect the ground. And again, you assess the harm. So Roomba has one sensor